Hi guys, how are you? This is Ali from Medicine Made Easy. Thank you for checking my YouTube. Today we will talk about a subject that's very important in physiology and in medicine. It is about anion gap, how we calculate it, and what the practical use. Let's define it first. Anion gap is the measurement of the difference between the negatively charged and the positively charged electrolytes. If the anion gap is either too high or too low, it may be a sign of a lung, kidney, GI, or other organ system disorder. Anion gap can be used to help identify the cause of metabolic acidosis. So mainly anion gap is measured if we have a metabolic acidosis. And it helps us to know what is the reason behind the acidosis. How to measure the anion gap? Simply, it is the difference between sodium and the um, chloride and bicarbonate. So first we measure the chloride and bicarbonate and we add them together and subtract it from the sodium. Sodium, as you know, normally is 135 to 145 milliequivalent per liter. Chloride normally is 95 to 105. Bicarbonate normally is 22 to 26. So normal anion gap in the books, everywhere you go and look for it, is between 3 and 10. Well, this is usually, we don't see it in practical use. Practically, or between the labs, it's different between the labs. Practically, the normal anion gap is between 8 and 16 milliequivalent per liter. What are the causes of high anion gap metabolic acidosis? That is 16 and above. Ketoacidosis, which happen usually in diabetes, lactic acidosis, that happen if we have an impairment of perfusion to organs in the body and ischemia, also renal failure if patient missing his hemodialysis, toxic ingestion, for example, of the toxic substances that can lead to high anion gap metabolic acidosis is the methanol and ethanol ingestion. High anion gap occur due to the low bicarbonate, which is below 24, and the low or normal chloride. So, because as you know, anion gap is sodium minus the chloride and bicarbonate together. So if we have a low bicarbonate but normal or low chloride, that means there is a way gap between sodium and bicarbonate and chloride, so the anion gap will be high. Causes of normal anion gap metabolic acidosis. Gastrointestinal bicarbonate loss, for example, vomiting, renal bicarbonate loss, and impairment of renal excretion. And for your information, normal anion gap occurs when the bicarbonate is low, below 24, but the chloride is high. That means the summation of bicarbonate and chloride, the summation is higher than the summation when both of them are low. Makes sense. So chloride is high, but bicarbonate is low. So when we subtract the number of the summation of bicarbonate and chloride from sodium, we're going to get a normal anion gap. There is no big difference between sodium and the summation of bicarbonate and chloride in this case. Let's talk about some extra informations. So if we have a high anion gap metabolic acidosis, we need to measure two things: delta ratio and Winter's formula. Delta ratio is calculated to help determine what is behind the high anion gap metabolic acidosis. And Winter's formula is applied to determine whether there is a respiratory compensation. Is it adequate or not? Because normally when you have metabolic acidosis, there is a respiratory compensation expected. So let's come to the delta ratio first. Delta ratio is the ratio between the delta in the anion gap and the delta in the bicarbonate. And how we measure it? The anion gap that we calculated minus 12 and 24 minus the level of bicarbonate. Normally, delta gap is 0 or is a range between minus 6 and plus 6. If it is 0 or between minus 6 and 6, that means what? That means there is only high anion gap metabolic acidosis exist. But what about if it is below minus 6? If it is below minus 6, that means there is a mixture of high and normal anion gap metabolic acidosis. What about if the delta ratio is above plus 6? That means there is a mixture of high anion gap acidosis and metabolic alkalosis. Okay, let's move to Winter's formula. Winter's formula, we are measuring the expected partial pressure of CO2, PCO2. What is the normal PCO2, guys? Normal PCO2 is between 35 and 45 millimeter mercury. So we measured the PCO2 at the beginning when we do the ABGs, the blood gas. And we take a blood sample and we measure the PCO2, one of the things we measure. So we have already a measured level of PCO2. So what is Winter's formula giving us? Winter's formula giving us the expected level of PCO2. And we compare between those two numbers. How we measure the expected level of PCO2? We measure it by 1.5 times the level of bicarbonate plus 8, plus minus 2. And we measure it in millimeter mercury too. So if the patient actual PCO2 or the measured one is the same as the calculated or the expected one, and guys, what is the measured or actual one? The one that we measured by taking a blood sample. What is the expected or calculated one? Is the one that we calculate by Winter's formula, just to make it clear as possible. So if the actual or measured PCO2 is the same as the expected one, or the Winter's formula one, that means what? That means the respiratory compensation is considered adequate. What about if the measured or the actual PCO2 is higher than the expected one or Winter's formula one? That means there is a secondary respiratory acidosis. For example, patient has poor perfusion and hypoventilation, like for example in cardiac arrest. So there is no way for compensation. What about if the measured or actual PCO2 is lower than the calculated or the expected one? This means there is a secondary respiratory alkalosis. For example, a patient with DKA. He or she is hyperventilating to compensate for the metabolic acidosis. I hope, guys, I made it as easy as possible on you. I know physiology is kind of complicated, but I try to make it as easy as possible. If you have a question or comment, please put it in the comment section. Thank you again for watching my YouTube. This is Ali from Medicine Made Easy. Good luck in your career. in your education, in your training, and your studying. Thanks a lot. Keep in touch, guys. Subscribe, like, and share. Bye now.